So we are going to find the general solution to dy dt equals 10 minus 2y. Now if this had been 10 minus 2t, we'd have just a basic antiderivative problem. But in this one, we are going to do separation of variables, and we're going to, because it's a y, it needs to end up over here. And so when we separate, we're going to get dy over 10 minus 2y equals dt. We've got to make sure we get our variables together, and we can only move things with multiplication or division. So basically I'm dividing both sides by 10 minus 2y. And we're going to do the antiderivative of both. This side is actually pretty quick and easy. It's just t plus c. I'll put my constant on that side. This one you might want to be a little careful of. It's actually not a bad antiderivative, but let's just do it over here on the side just so you can see where everything's coming from. 10 minus 2y. We could do this one with u substitution. So u equals 10 minus 2y du equals negative 2 dy. That means I need to put a negative 2 in here, which means I need a negative 1/2 out here. So I get negative 1/2 times the antiderivative. This numerator just becomes du over u, which is negative 1/2 natural log absolute value of u. We can put the plus c on there. We'll plug this back in. The negative 1/2 ln absolute value of 10 minus 2y plus c. We won't need the plus c for this problem because we've already put a c in there. So maybe just to differentiate, let's call this c1, c2, because they're not the same c. But there's my antiderivative. So negative 1/2 ln absolute value of 10 minus 2y. And I've got to do something with that negative 1/2. So I can multiply both sides by negative 2. That cancels that out. I get ln of 10 minus 2y equals negative 2t. And now instead of calling this negative 2c1, I'm just going to call it plus c2. If you wanted to have a note, I could say, okay, where c2 equals negative 2c1. We call it absorbing a constant. That negative 2 doesn't change the fact that it's a constant. We'll solve for it if we have an initial value later, which we don't for this one. Now, we need to get this out of a natural log. I'll make both sides exponents of e, so that gets rid of the absolute value, and I get 10 minus 2y on this side. Now here, this is pretty cool the way we do this. We have e to the minus 2c plus c2, but this is the same as e to the minus 2t e to the c2. And the thing about e to the c2, again, it's just a constant. So I'm going to absorb it into another constant. Call it, a lot of times you see people use a. Let's use a. So I get 10 minus 2y equals ae to the minus 2t. And all I have to do now is solve for y. Just do whatever algebra I need to get y by itself. So I may go ahead and start by subtracting 10. So I have minus 2y equals negative 10 plus ae to the minus 2t. And finally, I'm going to divide everything by the negative 2. So I've got y equals 5 minus a over 2 e to the minus 2t. And if I want, I can absorb this into another constant and write this as y equals 5 minus ce to the minus 2t, where c equals a over 2. So again, absorbing a constant. You see that quite a bit in general solutions of differential equations because eventually we're going to plug in some kind of initial value to solve for that constant. So why not have it as simplified as possible?